Hello everyone, welcome back once again. So today on chapter 8, we will be talking about testing of hypothesis. All right, so for 8.1, we have the elements of hypothesis we're testing. In general, what do we mean by hypothesis? Normally, hypothesis is a tentative statement you make for which the truth aspect of it is yet to be tested, or you need to get an evidence to actually verify the claim that you are making. So one of the jobs of statistician is to make statistical inferences about what populations based on what samples. So we get information from these samples and we want to make inferences about the populations. All right. As we move ahead, we are going to know what hypothesis is more in details, okay? But this is an overview of how it is. So here are some examples of hypothetical statements. So we have a car dealer who advertises that its new small truck gets what 35 miles per gallon on average. So that is what a statement that the car dealers actually make. So for us to verify this claim, we need to get what an information that will verify what the car dealer is saying. So we have a lot of examples as you can see. Okay. All right, so in this topic, what we're going to learn is we are going to conduct hypothesis tests on one sample means and one sample what proportions, okay? So we are going to conduct, so note this, note that, but we are going to begin with this, okay? And secondly, we are also going to learn about the errors that come from these tests, all right? If we are making our test, we could make an error. So what are these errors? We're going to learn it later on. And in hypothesis testing, normally we make some statements, and these statements we make them in two. All of them are contradictory to the other. If I say A, the other one will be B. So it's an opposite to other. It's an opposite to the what? To the other. And these are the hypotheses that we make. One of it is called the null hypothesis, and the other is the alternate what hypothesis. So the alternate will be a contradictory statement what the null hypothesis. And the null hypothesis, we write it as H naught, and the alternate hypothesis is written as HA. All right. So as you can see, we have the H naught, and we have what the HA. Sometimes we can write it as H1. Okay. And these are the signs that you have to note under these hypotheses. So for the null hypothesis, we always use what? The equal to, less than, or equal to, greater than, or equal to. So you realize that all of them has the equal sign in it. So it assumes the equality or what? The inclusiveness. And since you are making a contradictory statement, then it implies that if you use equal to, then you're going to use what? Not equal to. If you use less than or equal to, the opposite is what? Greater than. If you use greater than or equal to, use what? Less than for it. So you have to know how to write these hypotheses, okay? So you move ahead, we're going to learn a lot about what? These kind of what hypotheses, but this is just an overview of it. All right, so there are processes that helps us in testing our null and alternate what hypothesis. First of all, we write these what two hypotheses, the H0 and what the H1. Okay, then we collect sample because we need data to verify our hypothesis. Then we determine the correct distribution to perform the hypothesis. We perform some calculations and make a decision out of it. So as we move ahead, you're going to understand these steps further. Okay. The vivid definition about hypothesis. So a hypothesis is a statement about a population parameter. So we are focusing on the population parameter. But since you don't know the population parameter, normally we take samples and get some statistics out of it, and therefore test whether based on this information we can verify our hypothesis. Okay. So if you're focusing on the mean, we use the mu for the population parameter. If it is proportion, we use what? Our p for the population proportion. Right. So these are ways in writing what? The hypothesis. In case you're focusing on the mean, so one, if you under the null hypothesis, mu equal to k, that k could be any number, then the opposite of it will be mu not equal to k. We do the same if it is less than or equal to another h naught. Note that the null hypothesis always assumes the equality, and the alternate does not assume the equality or what? Inclusiveness. So notice very well, it's very important when you're writing it. Okay. So these are some kind of examples on or how we can actually write what or hypothesis about the mean. And when if you are talking about a proportion, then this is how we write it. But there's one thing you have to also note. We have directions for which we go in case we are testing our hypothesis. Always under the HA or the H naught, we use the signs on the symbols. And that is so if you pick an HA and there is not equal to, so not equal to means that we write our equal sign and cancel it. So not equal to means if you write this, you cancel it. It means not equal to, not equal to, okay? And we know our greater than, we know our less than already. So if it is not equal to, then it could be what? Less than or what? Greater than. So we have two directions. That's why we call it what? The two-tailed what? Test. So either we go to the left tail or we go to what? The right tail. But if you are using one direction, then with this direction, sorry, then under the HA, if we have this direction, it implies that you are going to the right what tail, you are going to the right direction. But if we have this direction, it implies that we are going to what the left direction. So we have the left-tailed what test. So these are the directions for which we might be using in testing our null hypothesis. So note we determine the direction that we are going to the what the H not the HA or the H1. That is the alternate hypothesis. All right, thank you very much. So in problems that we are going to solve, we are going to have some verbal statements about our hypothesis. So you wouldn't see it greater than like the symbol written for you already. Maybe that greater than, we might use another word for it to represent the greater than. So you have to write it back to what? Mathematical statement. So these are some verbal statements for which we can convert them back to what our mathematical statement, and these are verbal statement about our HA for which so all of these, so note it very well and how we write it mathematically. All right, normally our main goal is to actually make a decision. So the decision, what we do is that we make only one decision, and we either reject our H naught or what, or fail to reject our H naught. Since you are making two contradictory statements, if you reject H naught, then it implies that you are in support of HA. Okay, if you fail to reject H naught, it implies that then you've rejected the HA because you are still focusing on the H naught. Okay, that is it. So you make your decision based on the H naught, either to reject or fail to what? Reject. It implies that you are supporting the H naught. All right. So that is that. So these are some readings and further explanation of what I'm saying. Okay. So just as I said earlier on, these are mathematical symbols used in H naught and what? HA. So for H naught, we use the equal to, we use the greater than or equal to, we use the less than or equal to. It assumes the equal sign and the inclusiveness, and the HA does not assume the equal sign or what the inclusiveness. Okay, so note if I tell you to write a hypothesis test, you have to write H naught, HA, but where to put your signs, you should be careful with it. All right. So we have some explanations under it. So these are some examples for us to write our hypothesis. So we have to write our H naught and HA. But here we have a word problem, so you have to convert a word problem to a mathematical what statement or and use the right mathematical what symbols. So we have the average. So we are focusing on the mean. Average means mean. So the average temperature in July in Charlotte, NC has historically been. So the average is what? It's 1.3 degrees Fahrenheit. Perhaps it is higher now. So since it is higher now, we have it to be 81.3. So higher means it's greater than. Right? Okay. So in writing the hypothesis, we know that higher is greater than, and the HA assumes what? The higher. So we write what? HA. So we write HA or H1. Then we write this to define it. We are talking about average. So we use mu is greater than what? 81.3. Okay, if this is the case, then Your null hypothesis, always the null hypothesis comes, then the alternate. But you have to determine which sign do you want to actually write first so that the other one becomes very easy. So if you're able to determine the first one, then you can write the second one. All right, so mu is less or equal to what? 81.3. This is where the claim is, because perhaps it is higher now. So this is where we are claiming. Okay, so we write the claim here. Always the claim, the sign doesn't change. Then if it is less or equal to, or it could be what? Equal to. So either you use this symbol instead of that, or use this instead of that. Okay, all of them is accepted. Just that you don't have to use this under the H naught. Otherwise they have the same sign. You are not making any contradictory statement. The same analogy applies to all of them. Okay, so you have the same analogy. All right, so the average weight of a new baby of a newborn puppy is no more than 15 pounds. If it is no more than 15 pounds, it implies that it is less or equal to. But since you have inclusiveness here, then it implies that you have to put it under what? H naught. So here, if you have to write it, then you write the inclusiveness what here and put the claim there, because that's where the claim is. Then the alternate will be the opposite of what? The H naught. We do the same for the others. Okay, so in case you are going through and you don't understand anything, please do well to email me and I'll be glad to explain it further. All right. So very important. The test procedure is based on the assumption that our H naught is true. So before we start, we assume that our H naught is true. Now we need evidence whether to reject the H naught or fail to what? Reject it. Okay. And in this process of rejecting or failing to reject, we come out with some errors. And these errors has been categorized into two. We have the type 1 error and the type 2 error. In summary, when we talk about it, a type 1 error, it implies that since we are assuming that H naught is true, and if H naught is true and we reject it, it implies that we've committed an error because it is true and you are rejecting it. So that is an error, and that error is called what? The type 1 error. So that error is type 1 error. Okay. And the type 2 error says that H naught is false, but you are failing to what? Reject it. Something that is false, you should reject it, but you are failing to reject it. Then it implies that we are committing an error known as what? The type 2 error. Are you okay? So the type 1 error means that we think HA, meanwhile, but in reality, it should be H naught. And type 2 means that we think H naught, but in reality, it should be what? HA. Okay. So these are the explanations, the errors that we make in testing our hypothesis. So we put this. So this is the explanations of the type 1 and type 2 error, just as I did, and we've put them into a table. It implies that we have H naught to be true. Let me explain the table. If H naught is true, and we make a decision, do not reject H naught, we make what? The correct decision, because it's true. So we fail to reject it. But if H naught is false and we do not reject it, we've committed an error known as what? The type 2 what? Error. And now if H naught is true, okay, and we reject it, we've committed an error because it's true and we have rejected it. So it's called the type 1 error. And if H naught is true, and if H naught is false and we reject it, it's a correct decision. We've not committed any error. Okay. All right. So this is what the table actually means. Now, if you commit an error, you want to know the chance or the probability of committing that error. We don't want that error to be big. All right. So we denote it by alpha. If you commit, the chance that you commit a type 1 error is called our alpha. Okay. And the chance that we commit, that is the probability that we commit a type 2 error, is called what? Beta. Okay. We are going to learn further about the power of our tests later on. Okay, so You know that in previous lectures we've talked about level of significance. So you can decrease the probability of this happening by what? Okay, so when we talk about the level of significance in hypothesis, the level of significance is your maximum allowable probability of making a type 1 what error. We don't want to make a lot of errors. So it is denoted by alpha, and that of the probability of committing a type 2 error is denoted by what? Beta. That is what I've actually explained early on. Note that each of the errors occurs with a particular probability. All right, so this, I've actually explained that. I've explained the alpha and I've explained the beta. That's the chance that you commit any of the errors. But sometimes we want to know how powerful our test is. So for you to know how powerful your test is, that is, you can make the correct decisions, then you subtract your type 2, the chance that you make a type 2 error, from 1. And that will tell you how powerful your test is. Okay, so that is the power of our test. That is the power of our test. But if we increase our sample size, maybe in a population, if you're able to get a lot of information from that population, we increase the power of what? Of our test. Increase the power of our test. So here are some examples, and out of these examples, we want to write the type 1 error and type 2 errors out of it. Okay, but before you can write your type 1 and type 2 error, always make sure to write the hypothesis down, because you're going to reject or fail to reject and make those what errors. Okay, so suppose we have the null hypothesis that the victim of an automobile accident is alive when he arrives at the emergency room of a hospital. So this is what we assume. That's the null hypothesis. So you have to write alternate will be the opposite of what you've written. So the alternate is that is dead. The person was already what? Dead. Okay. Okay, so since you've written these, you've written your H naught and you've written what? Your HA. Now, type 1 error means that you think that it is this, but meanwhile it is that. Okay, what you think and what. So we reject H naught, and meanwhile H naught is what is true. So what do we think? If you reject H naught, then it implies that you are conforming to HA. So we reject H naught when in reality it is true. Okay. So how do you write the statement? So the ACQ thought that the victim was already what? Dead. So you're going for HA. Okay, this is HA. When he arrived at the ER of the hospital, when in reality he is still alive. So this is our H naught. It is true. Okay, we assume that is true. So this is a more serious error. This is a more serious error. So what could be the type 2 error? So type 2 error means that, what could be a type 2 error that we commit? The type 2 error means that we are in support of what? We are in support of H naught. Meanwhile, it is what? It is false. Okay, in reality, it is false actually. So if you are in support of it, then we think that the person should be what? We think that the person is alive. Meanwhile, in reality, the person is dead. Okay. So that is a type 2 error. So we fail to reject this, means that we are certain that. Then we are rejecting that. Okay. So we think this. Meanwhile, it should be that. Okay. That is the type 2 error. Right. So we make these errors. So first of all, for you to write your type 1 and type 2 error, you should be able to write your H naught and HA. Then you go for the, if you're writing the type 1 error, go think type A, think HA. But in reality, it should be H naught. And if you are writing for the type 2 error, then you think H naught, but meanwhile, it should be what? HA. Okay. That is how you're able to actually write them. So first of all, determine your H naught and HA based on the statements. Okay. Okay, so all these are some examples. All right. All right, let's move on to section 2 very soon.